What's up, everybody? I'm Matt Gary, and welcome to the extremely long-awaited episode 4 of the Design Pattern Tutorial series in Apex. In this episode, we're going to go over what inheritance is in software development in general, but more importantly for you all in Apex. We'll figure out what it is, when to use it, why it's important, and the most important thing of all, we'll write some code together in Apex so that you can see it live in action. So, let's get to it. All right, everybody. So today we are going to be going over inheritance in Apex, and generally speaking, inheritance in any object-oriented programming language, whether that is Apex, Java, C#, who knows. Inheritance will be the same general idea in any of those object-oriented programming languages. Just the way that you do it will differ a little between the languages. So, cool. We're going to figure out what inheritance is, when to use it, why to use it, and most important, we'll do an example that's relevant to Salesforce so that you guys get a better understanding in the context of Salesforce when you might use inheritance. But before we get any more into the magic of inheritance, make sure if you actually enjoy this video to like it, because when you do, it helps it get out to more people just like you that want to watch this stuff for free too. So you enjoy the video, like it. If you really love it, subscribe. And now, let's get back to the video. So, cool. First thing is, what is inheritance, right? And basically, inheritance is a pretty good way of reducing, of reusing your code across multiple classes within your code base, right? Inheritance is going to give you the ability to take code from one class and use it tons of other places, as we'll see in just a moment. It is important to note, though, that while inheritance is useful, it's probably not the most useful way of reusing code in your system because of some of its fragility problems, which we'll go into later. It can get... There are other options that are a lot more flexible, I would say, such as composition. So while we're starting with inheritance because it's a super important and fundamental concept of object-oriented programming, I would say don't stop there because there are other tools or object-oriented programming concepts like composition that may facilitate themselves better in more scenarios. So, just so you know, there are other things out there, but that's not what we're here to talk about today. We're here to talk about inheritance, which is still super useful and important to understand. So, again, inheritance is a way to reuse code across your code base really easily. And one of the most common examples that you see out there on the internet when you look up what is inheritance is the scenario where you're building some theoretical system. I don't know, maybe you're a game developer and you are developing the next Need for Speed Underground. Should be magical. They could set that up for me. But maybe you're a developer, you're creating a game, and it has tons of different types of cars in it, right? Well, as you and I know, there are probably hundreds, if not thousands, of different types of cars in the world. And, so potentially thousands of cars you could put in your game. And even though there are thousands of different types of cars, most of them have very similar functionality. You can start the car, you can stop the car, you can turn the air conditioning on, you can turn the radio on, you can pull the e-brake. I don't know. There's a bunch of different things you could do depending on what you're trying to program into your game. But basically, even though there's thousands of types of cars, most of them share a huge chunk of the same functionality. And that's where inheritance comes into play. So, as an example that's not really relevant to Salesforce, but is easy for anybody's brain to latch on to, I think, I've got a couple of classes or a few classes that represent cars. The first one is a Lambo, you know. For someday when I get that Lambo money, which is not going to happen for me. I don't have any aspirations for Lambo money, but say you've got a Lamborghini in your game, right? I need to tell the game, you know, how many wheels, how many doors are on the Lambo, how to start it, how to stop it, all that kind of stuff. So I've created class properties or variables to denote the wheels in the door, and then I have methods to give it that functionality of starting and stopping. And then maybe I also want to create a Buick, which is another type of car for those who are not super familiar. And it has wheels, it has doors, you can start it and you can stop it. And you can already see just between these two types of cars, I've duplicated a lot of code. And it would be great if I could just only write this once and use it in both classes. And this is where inheritance comes into play. So both a Lambo and a Buick are a car. So here is a car class. And for this car class, I've created it as a parent class, or in Salesforce, it's denoted as a virtual class, in Apex specifically. It's denoted as a virtual class. And by creating this Apex class with the word virtual in it, I'm allowing it to be extendable or to be a parent class of other classes within my code base, right? So I've created this car class and I've given it the ability to be an extendable parent class. And I've given it all those things that we saw before. Wheels, doors, the ability to start a car, the ability to stop a car. I'm going to change these to public so I don't get in any trouble here in a second. And keep it a little simpler. And now what I can do, because I have this parent class, is I can go back to my Buick. I can delete literally all of this. And I can say my Buick extends my car, like so. And now what happens is my Buick gets every single property of my car that is either a public property or method, or, as I had before, a protected property or method. It gains access to all of the functionality in this car class just by extending it, like so. We can do the same thing in Lambo. We can delete all this junk and just say extends car. And now if I save both of these, or all of these, we're going to see when I write an anonymous Apex script that I can instantiate a Buick now, and I can call the start car method from my Buick class. So over here, I've created an Apex anonymous script, which, if you're not familiar how to do this in VS Code, if you're not familiar with VS Code in general, and you're looking at this and you're like, whoa, I don't know what this is. I've only worked in the dev console or something crazy at this point. I do have a video that shows you how to set up Visual Studio Code. I'll link it up above. You can go check it out. It takes just a couple minutes to set up. Then you come back here and it all makes sense. But I've set up an execute anonymous script in my Visual Studio Code. And you can see here, I've initialized the Buick. So I've instantiated a new Buick. And I am calling Buick start car, right? Which, again, it doesn't actually have that in the class anymore. It has it in the car class. And so what we should see, if this works, is a debug statement of car started. So let's come back over here. Let's execute this script. Bring it up. See if we got that debug, and we did. Let me make sure my giant head's not in the way. It's not. You can see right here that when we ran this, we got the debug of car started, which is awesome, right? And we can also, you know, say Buick.stopcar, like so, or Buick car.stopcar. And then if I execute this, you can see that I started my car and then I stopped my car. Pretty cool. So that has allowed us, as you can see, to remove an enormous quantity of code. Well, I mean, in our case, it's like 10 lines, but in theory, it'd be a huge amount of code, and allowed us to reuse it in a bunch of different places. Now, you might be wondering, all right, well, okay, fine, but like, you know, my Buick, it starts different than my Lambo. You know, my Lambo's way cooler. It should make louder noises. And my Buick is from 1987 and it shouldn't start at all or something, you know. Well, that's okay, because in the instance that your method varies from your inherited method, your child class's method should differ from your parent class's method, there's a solution for that. It's a virtual method. So I've declared these as virtual methods, which means that we can override them by just taking them, bringing them over here, saying, saying override start car, and then I could say my car is garbage or something, which isn't true. You know, Buicks were pretty good. I mean, they're not great, but they're not garbage. And and now if I ran my Apex Anonymous script again, we'll see that we got a different debug log. My car is garbage, right? So it still gives you the flexibility, if you should need it, to change these methods to do something unique for each individual class, if that was a necessity. So at a high level, you can kind of already see, right? You could, in theory, really reduce the amount of code in your code base by leveraging inheritance in your Apex classes. So pretty useful. Now, you're also probably wondering, if you're like me anyway, okay, cool, you just did that for cars. Like, what's an actual real world example for Salesforce, right? Because we're not making cars in Salesforce. When the hell would you ever use inheritance in Salesforce? Well, fair. But there are situations, and you can maybe already start to envision them if you've written a lot of code in Salesforce. But a good example, I'd say a halfway decent example anyway, is say like a lead scorer, right? Yeah, I'll just put it there. Maybe I have leads, I have set up leads in Salesforce, and I have a scoring system for my leads, but I have like 4 or 5 different groups in my org, and they all want to score, but they all have, you know, semi-unique ways of scoring. Maybe. I don't know, but possibly. So I've got my lead scorer, and I'm going to close my car classes so they get out of my way for a second. I've got my lead scorer, which I'm going to make my parent class, and then maybe I have one for like marketing. Oops, I got to actually do the command first. Marketing lead scorer. And then maybe I have another one for like sales. Oh, if I could run the command, sales lead scorer, right? Something like this. And we know that for every single one of these, we need to calculate the score. So we create like a public virtual void score. It's actually not a bad suggestion by the AI there. And then, maybe we need another one that's like public virtual void, I don't know, convert the lead, something like that. So now we have these couple of methods, and I know that in basically every situation I want to convert, and I also need to score it. Well, now for our sales lead score, instead of having to implement those individually, I can just say, extends lead score, and I get access to whatever my general conversion method was or scoring method was. So there are places, even in Salesforce, more often than not, especially when you get into larger orgs, where you're going to see this reusability potential show itself, I guess, right? This really comes in handy in Salesforce orgs when you've got a lot of apps or a lot of stakeholders that have different, relatively similar but slightly different functionality across their usage of the same object or whatever, So this would be kind of one general example of when you might use it. Now, as you can kind of see, the one drawback to inheritance is it's kind of fragile, right? And it kind of loses its usefulness the more that your child classes divert from the base class, right? So if I'm creating a lead score in both my sales lead score and my marketing lead score, wherever that disappeared to, yeah, there we go. And both of them use the exact same implementation of convert and score. Cool. That's great. But maybe I also have another method here, but maybe, I'm getting ahead of myself. Maybe I create the marketing one and it doesn't actually need to use score, convert ever, rather. Everything needs a score or else it wouldn't be called lead score. But maybe the marketing one doesn't ever need to convert. And maybe I have like 5 other methods in here because I thought I was going to need them because I created the sales lead score first. But then I created the marketing lead score and I have like these 5 other methods below here, method 1, method 2, method 3, blah, blah, blah. And I've got all this functionality that I'm now piping into my marketing lead one when only my sales lead one actually needed it, right? So I'm basically kind of forcing it to inherit all this junk that it doesn't need, it doesn't want. And so it's really important to know that while inheritance is super useful, it can start to break down and become less and less useful when your classes don't actually benefit, your child classes start to benefit less and less from the parent class. So that's just something to look out for. When you use inheritance, you want to try to make sure that the classes that you're using are, generally speaking, using the majority of the parent class that it's actually inheriting functionality from. Otherwise, you're just piping in stuff that you're never going to need and might actually, prove to be more irritating than helpful, right? And this is why I said kind of at the beginning that the concept of composition is oftentimes more useful than inheritance, because you very often in inheritance, down the road, one way or another, get into this situation where you've got this big giant parent class and your child classes use almost none of it, or they override, you know, all of the functionality of your parent class anyway. So I've gone way off on a tangent here. I probably shouldn't have even gone that in depth into its, you know, where inheritance falls off. But, you know, I tend to talk too much in these probably. Anyway, so now you have a good idea of when, where, why, all that kind of stuff to use inheritance. Use inheritance to reduce code in your code base. When you use it, you'll use it when you have two child classes, like marketing lead score and sales lead score, that are very similar in functionality, and you would like to reuse that code across them easily without having to maintain it in a couple places. Yeah, and why. I think I summed up why too. I don't need to restate it. So, cool. Now you have an idea of what inheritance is, when you should use it, why you should use it. In the next episode, we are going to go over what? I don't know. It's been a million years now. In the next episode, we're actually going to go over what polymorphism is in Apex, and then we're going to get into the Gang of Four design patterns, along with plenty of other stuff. So, cool. Yeah. I know it's been a few years since I made the first one of these, so, you know, welcome back. And hopefully I see you in another one real soon. Until then, I'll see you later.